Okay, this is part two of a video in which I give some rambling, improvised, one in the morning type answers to some questions posed by my friend Randall Kona as part of a carbon copies workshop on mind uploading, brain computer interfacing, AGI, and so forth, which was held in a part of the world far away from me. So, in lieu of showing up and rambling semi-coherently at the audience, I'm doing so on video from afar. So let me continue with some of Randall's questions. First question, what do I think about brain-computer interfacing as a tool to improve AI safety? What impact would high-speed brain-computer interfacing have on AI or rapidly self-evolving AI or AGI? All right, well, brain-computer interfacing could either greatly aid with AI safety or could terribly harm the prospects of safe AI. It really depends on how it's used, right? I mean, on the beneficial side, if we want our AGIs to richly understand human values, connecting to the human brain is going to be a really nice way for an AGI to suck some values out of the human brain, right? I mean, of course, AI can learn human values by watching people and by enacting human values by controlling robots and other agents in the human world. But to the extent that that an AI can inspect what happens in the brain, it may come to understand human values even better than human beings do in many senses. So that's quite positive. On the other hand, you if we look at selling, spying, and killing as the main pursuits of the AI sphere in the world today, given the big tech companies and governments that are controlling so much of AI today. I mean, then how could brain-computer interfacing be used for selling, spying, and killing? Well, you could invent a lot of interesting ideas that way, and would they lead toward AGIs that are going to be positive and beneficial toward humans, other sentient beings as they expand their intelligence? Well, quite possibly not, right? Randall's next question. Could you create high bandwidth brain-computer interface without first having a neural prosthesis or a completely artificial brain? Well, I mean, I think that the brain is very adaptive, and probably if you stuck a bunch of data from a computer into it, the brain would make some interesting sense of it. I mean, there would then be no longer a legacy human brain. You might, I mean, the more complex and novel the data coming into the brain is, the more the brain would have to morph itself to encompass this data. But that would be quite interesting. You're creating a hybrid mind. I mean, of course, you get to a certain level where the brain no longer has the capacity to adapt to what you're trying to interface with it. But what exactly that level is, we don't know enough about neuroscience or information processing in general to know that. Now it probably will be determined by experiment. I probably will not be the first person to volunteer for that experiment, but I'll be fairly early on, right? So this will be quite interesting to see. I do think it's important to remember that, once you get into nanotech, femtotech, the amount of intelligence you could pack into a grain of sand would probably be a quadrillion times the human brain and trillion or something times any brain-computer hybrid, because, I mean, the human brain is a very inefficient way to do information processing, creativity, probably an inefficient way to manifest consciousness compared to, what's possible in an engineered physical system, permissible even according to the known laws of physics, let alone to what the laws of physics may be understood to be after a singularity. So while, upgrading human intelligence by connecting brains to computers and creating hybrid minds is interesting. This is, in the scope of post-singularity minds, these hybrids are going to be closer to a monkey or a frog than they are to a super intelligence, right? So it's an interesting thing to do in terms of the transition between here and post-singularity minds, but in the end, it's just a baby step toward the singularity. Randall's next question: do you see ways in which whole brain emulation, an artificial human brain, might immediately present an existential risk to humanity? Well, I mean, if you emulate some nasty human and then copy that emulated nasty human 1,000,000 times and connect its body to, selling, spying, and killing machines around the world, this may not be good. But again, it's not really about the technology. It's about how it's used, right? I mean, my guess is that if you compare a whole brain emulation to an AGI built according to some, rational, non-brain emulating architecture, like, let's say an OpenCog system that works really well, I would guess there's both more benefit and more risk in the engineered non-brain emulating design, because I mean the human brain is not made for self-modification. When you start enhancing intelligence of certain parts of it, other parts are going to break, and you're going to wind up not being able to enhance its intelligence tremendously without basically replacing it with a totally different architecture, because the human brain is an adaptation to certain resource constraints. And once you release those constraints, you're going to need to change the architecture to manifest the intelligence that is possible with the new expanded set of constraints. So I think, on the other hand, a rationally architected AGI, such as what we're trying to do with OpenCog, or could be something different than OpenCog, with something engineered with self-modification and, rational self-understanding in mind, this sort of AI system, it's going to be able to reprogram itself. It's going to be able to study itself. It's going to be able to replace one module with an upgraded module. It's going to be able to audit all its states and then rationally make decisions as to what possible improvements of itself to try. It can go far, far ahead of a human augmented with a brain-computer interface or an uploaded emulated human, and it could go far ahead of these human-esque post-human minds in a good or a bad direction. Again, the technology has a lot of potentials. It depends on what you do with it, and of course, what you do with it will guide what it does with itself, right? And Randall asks, rapid self-improvement is often described in the context of utility function optimization and reinforcement learning. Reinforcement learning may be accomplished only in a few of the many complex subsystems of the brain, like neocortex and cerebellum. So do you think a whole brain emulation could rapidly self-improve? Well, that's a really delirious and misguided question, Randall. I mean, I think it's true. Only a little bit of what the brain does is reinforcement learning. And that's why the brain can be intelligent, because reinforcement learning is a terrible overall paradigm for general intelligence. I mean, reinforcement learning is only a tiny bit of what the brain does, just like deep hierarchical pattern recognition, like current deep neural nets do, is only a very small part of what the brain does. So, yeah, I mean, rapid self-improvement can go much more rapidly if it's following methodologies besides just reinforcement learning. The reasons that the human brain can't rapidly self-improve are more that it's architected in a contorted and limited way, where each part is dependent on the other parts, and each part and their dependencies evolve to work within certain processing constraints, which aren't compatible with the transhuman intelligence that we want to build. I mean, it's just like you can't take a horse and double its size and have it still work. I mean, if you increase the short-term memory capacity of human to 10,000 instead of 7 plus or minus 2, the connection between short and long-term memory and medium-term memory isn't going to work. The relation between declarative and procedural knowledge and short-term memory isn't going to work. A lot of other changes will have to be made all around the brain. Whereas if you have a rationally architected AGI system and you increase its short-term memory capacity, if it's written well, you could probably just use some automated code rewriting system to tweak the other parts of the AGI system to properly accommodate for the expanded short-term memory of the AGI system. So I think there are limitations in speed of self-improvement that you're going to get in a brain emulation or brain incorporating AGI system, but these aren't to do with the limitations of adherence to the extremely narrow and limited paradigm of reinforcement learning. These are more to do with just the constraints of being an evolved system as opposed to an engineered system mostly. I mean, evolved systems can evolve and evolution is slow and messy. Engineered systems can be engineered, which can be much faster. Engineered reflective systems can self-engineer, which is going to be really, really nice and way faster and way more efficient than the mess of evolution. Randall asks, there's an argument cautioning against a strong push for neurotechnology and whole brain emulation because work in those areas might accelerate advancement toward runaway self-improving AI. Well, as I already said, I think this particular line of research of whole brain emulation is a terrible approach to self-improving AI. So if you think self-improving AI is bad, you should be in favor of AI through brain emulation. If you want self-improving AI, you should be looking at engineered AI systems that are designed for rational reflection and self-understanding and self-modification. Next question from Randall. There's an argument the ultimate solution for AI safety is a scenario for human and AI becoming inextricably entangled. Well, again, there's no reason to think that will guarantee safety. There could be good and bad aspects. I mean, if you're taking, a very powerful artificial cognitive system and coupling it with these reptilian/mammalian motivational systems and emotional systems we have in humans, this could be pretty damn nasty, right? I mean, an OpenCog system is one example of a non-brain-based system. It has a certain set of goals. They don't drive all dynamics in the system, but they drive a significant amount of it. They have a certain set of goals, and then the system, rationally, using probability theory and logic, chooses which actions are most likely to achieve its most important goals in the current context. I mean, it's not driven by its body and its emotions and its instincts to the extent that a human being is. And I think something like that is probably going to be, if it's done right, it's going to be safer than some weird Frankenstein thing, Frankenbot thing with these evolved motivational and emotional system latched into some artificial cognitive system. So we don't know because we haven't built an AGI based on the human brain or brain-computer interfacing or OpenCog or anything else yet, right? So we don't know. There's tremendous and very hard to reduce uncertainty here. But my own instinct and my intuition, and I've thought about this a lot, is that it's going to be a lot more dangerous to mix up in one system all this nasty mammal reptile stuff with artificial cognition. I mean, I think you want the rational, reflective, self-modifying AGI to understand human culture and human values and to have compassion for humans, but you don't really want it to be a human. You want there to still be humans, but you don't want to try to do something screwy like make it so the smartest and most powerful minds are some sort of human AGI Frankenbot thing. I mean, you want to accept that humans are just a limited form of mind. I mean, there's beauty in this limitation as well as hideousness in this limitation, but that's what we are. And one of our beauties is that we can build fundamentally superior minds, which are compassionate toward us and can self-understand, self-modify, and self-improve in ways that we intrinsically cannot due to the way that we evolved. And we can then coexist with these superminds, but we can't be these superminds. And trying to create a supermind that's tied in with the human, mammal, and reptile control system is far more risky than most other, maybe than any other technology on the horizon. Final question from the great Randall. In your opinion, what should humanity do to maximize its long-term chances for survival and thriving? Give Ben $50 quadrillion. No, well, all right. Apart from that, I mean, very clearly, what humanity should be doing is spending a large percentage of its resources on globally beneficial applications of advanced technologies, including AI, nanotechnology, neurotechnology, and so forth, and on trying to create machines with compassion toward humans and deep, rich understanding of the full breadth of human values. And we shouldn't be, putting the bulk of our AI resources into selling, spying, and killing. We shouldn't be putting so little resources into medical applications of advanced technology, into education, into agriculture, into artificial poets, scientists, social workers, nurses, preschool teachers, and philosophers, and so forth. So I mean, if you look at it from the outside and you had a species that was on the verge of creating the first mind's more intelligent and powerful than itself, you might think a large percentage of that species' resources was going into, figuring out theoretically how to make these new minds be as beneficial as possible for the universe and the multiverse and for the species doing the creating, and to prototyping different kinds of beneficial engineered minds, and to making sure that engineered minds, as they increase in intelligence year by year, were working closely in a positive and compassionate way with the species that created them. I mean, instead, almost all AI development now is driven by commercial or military ends, and the same for medical technology, the same for nanotechnology. I mean, almost all this technology is being developed either so that one country can achieve like military hegemony over other countries, or so that one company can extract money from other people. So that, I mean, the fact that our technologies are being developed mostly out of tribalistic or greed-based motives clearly isn't good. We want to be developing these technologies, in a way that is motivated and is explicitly driving toward broad benefit for humans and for the other minds that are going to be created. That's not what we're doing, and that's what I'm doing. I'm trying to develop advanced technologies in a way that will help all of humanity and will help the superhuman minds that we're going to create, and throw in the animals and plants and the rest of the ecosystem and any other aliens we account in this or other dimensions as well. But most development of advanced technologies is being driven by very narrow, sort of tribalistic or ego-based goals, and this is not optimal. Of course, you can't solve that problem top-down all at once. Hopefully you can solve that problem by unleashing sort of new methodologies into the world. I mean, just as open source transformed the software world, perhaps decentralized AI networks can transform the AI world and cause AI to self-organize in a way that's more inclusive, democratic, and participatory, so that as AGI emerges out of narrow AI, it's emerging with input from users, developers, and participants in AI around the world, and is reflecting a broad range of applications and feeding on a broad range of human insights and feelings and intuitions. All right, it's about 1:30 a.m. here. Clearly I'm becoming less and less lucid as this ramble continues, but hopefully I've given you some flavor of my views on these issues. So thanks, Randall, for inviting me to participate via video, and hopefully next time I can show up in person.